And I'm back. So I foreshadowed in the previous video that I was going to show you how to use the quadratic formula to tell you how many solutions a quadratic is or has. So we've learned before that it could have two solutions if you're crossing the x-axis in two spots. You could have one solution, and that's going to be your perfect square trinomial cases where you are just touching at that one spot where the vertex is on the x-axis. But you could also have a quadratic that's been shifted up or down in such a way that it never actually touches the x-axis, and in those cases we say it has no real solutions. So I'm going to show you how to use the quadratic formula. A lucky thing about mathematics is you don't actually have to do the entire quadratic formula before you can realize that there's no solution. So there are scenarios, like I said, where you will have only one solution or even no solution. So to figure that out, we are going to look at something called the discriminant. The discriminant is just a little piece of the quadratic formula. So if you can just zero in on that discriminant, then you don't have to worry about working through the whole quadratic if you suspect that it's no solution. So the discriminant is the portion of the quadratic formula that is underneath the square root or underneath the radical sign. Therefore, the discriminant can be found using b squared minus 4ac. So it's just that little bit right here underneath the quadratic, this b squared minus 4ac. So let me go ahead and show you an example of how this would work. So in order to find the discriminant, first I do have to put this in standard form, so I'm going to subtract 10x, and I get 3x squared minus 10x plus 3. Notice I put that in the middle because I like to have it in descending order, my x squared, then my x, then my 3, because that's truly standard form. Alright, then I think I'm going to have to move myself over here so that I have more space to write. So now my a value is 3, my b value is negative 10, make sure you put that negative, and my c value is 3. The discriminant uses all three of these values, so make sure you identify all three of those. It is b squared minus 4 times a times c. So my a is 3, and that's going to go right here. My b is negative 10, and that's going to go right here, making sure to put that in parentheses so that I square the negative. And then my c is right here, and that's going to go right here. Okay, so let's go ahead and plug those in. I'm going to have negative 10 squared minus 4 times 3 times 3. They won't always be the same, obviously, but in this case, my a and my c are the same. So I put my a here, I put my b there, and I put my c at the end. Oops, and I put it in the wrong spot. Sorry. I put that c there. Alright, so now I'm going to just use the order of operations. Negative 10 squared is 100. I can go ahead and do my multiplication. Negative 4 times 3 would be negative 12 times 3, which is negative 36. And 100 minus 36 is 64. So the value of the discriminant is 64. Now, if I were trying to actually solve this, then I would still have a lot more math to do. But using the discriminant, we can answer our question, how many solutions do you have? If your discriminant ends up being positive, then you have 2 solutions. If your discriminant ends up being 0, that is a situation where you'll have just 1 solution. And if your discriminant is negative, then you'll have no solutions. So really quick, I'm going to go through and do some examples for you. In this case, I have 9x squared. I'm going to subtract 20 from both sides because I want to put it in standard form. Even though there is no b value, I can still use my quadratic formula. And I can still find the discriminant because in this case, a is going to equal 9. B, because there is no b, it's going to be 0. and c equals negative 20. So b squared is going to be 0 squared minus 4 times a, which is 9, times c, which is negative 20. So 0 squared is 0, and then negative 4 times 9 times negative 20 is positive 720. Because I got a positive answer there, I know that there are two solutions. That's a positive 720. In this one, my A is equal to 1, my B is equal to negative 2, my C is also equal to 1. So when I plug those in, I get negative B, I get B squared, which is negative 2, had to think for a second, negative 2 squared minus 4 times A times C. Negative 2 squared is 4, minus 4 times 1 is just 4. 4 minus 4 is 0. If my discriminant has a value of 0, then that is one solution, or one real solution. Okay? On this last one, again, I've got to get everything on one side, so I can subtract the 3m and add the 3. So I'm going to do the same thing over here, subtract the 3m, add the 3, and I get 12m squared minus 3m plus 3 equals 0. So my A value is 12, my B value is negative 3, and my C value is positive 3. I always want to go negative B plus or minus square root of B squared. I'm only looking for the discriminant, which means I only need B squared minus 4AC. B squared is negative 3 squared minus 4 times A is 12 times C is 3. Negative 3 squared is going to be positive 9. Negative 4 times 12 times 3 is negative 144. And when I subtract 9 minus 144, I get negative 135. A negative value of the discriminant means there is no real solutions. I want to talk about why that is really fast. I know you're probably pausing me now to go do the U-tries, but I'm going to keep talking anyways. Because the reason that that's no real solutions is because, remember, the discriminant is the part that's under the radical. Well, if I try to take the square root of negative 135, which is what I would have to do if I were doing the quadratic formula, then, well, let me show you. So I've got typed in square root of negative 135. When I hit enter there, let me get you, there you go, if I can find the enter button, then I get domain error. That's because we can't take the square root of a negative. In future math classes, you'll learn a way to deal with that, but for now, let me just tell you, you can't take the square root of a negative. So if you can't do the quadratic formula, that must mean there's no solution, because the quadratic formula always works. Even when there's no solution. If there's no solution, you're just going to get a domain error, and then you know, oh, okay, well, then that can't be done, so there's no solution. There's no point where this quadratic crosses that x-axis. All right, so that's it for this video. You're going to go ahead and find the discriminant and see how many solutions. You don't have to actually find the solution here unless you want to. You just got to tell me how many would there be if you were to find it. And then I'll see you back in a minute for one more word problem. Bye.